vibes to our conference today, our acclaimed speaker joins us from Intel, India, wherein she works as a principal AI engineer. She brings around 20 years of industry experience and has deep expertise in a wide range of qualitative and quantitative techniques in big data, IoT, NLP, ML, and cloud native computing. She holds a master's in computer science from ISI Kolkata and a BTech from the very esteemed IIT Kharagpur. She is joining us today on the DOI stage to share her deep insights to mitigate bottlenecks in AI engineering through our power-packed talk, Demystifying MLOps. With that, conquering your screens right now, let's welcome Ms. Ruma Mukherjee.
Hi everyone, welcome to the session. I'm Ruma Mukherjee from Intel, and I have been working in the AI industry for around a decade now. So today I would bring up one of my favorite topics, MLOps. A couple of years ago, the machine learning community's prime focus was towards building models, training hyperparameters, or picking up the right machine learning algorithm itself. It was to a great extent confined to the research labs only. But the situation today is very, very different. The AI industry has made great progress in actually deploying ML models for being used by the consumers of their business. It would not be very wrong to say that deployment of machine learning models into production is a lot more time and energy than writing the machine learning code itself. So it is a very, very effort-intensive engineering work. So here comes MLOps, machine learning operations, which is an exciting nascent discipline supporting the entire life cycle of a machine learning project execution. MLOps is very much on the cutting edge of technology, and I'm really excited to demystify the concepts of MLOps today in this forum. As we all know, there's a growing hype around the emerging technologies like AI and ML. But the question is the industry at all ready for real business in AI? Companies have hired many data scientists, which have resulted in countless proof of concepts or minimal viable products, MVPs, in the AI world. But now what? So let us talk of my experience a bit over here. So not even 3 to 4 years back, this was almost the situation everywhere. So a team of data scientists sitting in one corner of the world was creating fine-tuned machine learning perfect models, showing some impressive visualizations, all in their laptops, in an RStudio or Jupyter notebook, using a language of their choice. Everyone was impressed. We were POC complete. The data scientist team got an award, and we thought that we are all set for the next big business in AI. But what was the real story behind this? Now came the hard time to put things in production. Right? So our data scientists were not professionally software engineers. So they did not understand the scale of deployment, distributed computing, continuous monitoring, or the CI/CD kind of deployment issues which exist in the IT industry today. So what did we do then? We called the data engineering team. This was a complete parallel organization. They half understood the machine learning models and had no idea what or how data was used to create those models, no idea of model validation, and of course, a huge communication gap between the data scientist team and the data engineering team. Right? What did they do? What did the data engineers do? They were great coders. So the first thing they did is to start coding. They ported the machine learning models line by line from R to Java, replacing the libraries of R with what they thought are the equivalent Java libraries, okay, through random internet search. And what was the result? Big performance reduction in models with long, inconsistent, and non-standard model deployment. So this increased the anxiety in the data teams, and the AI projects lost funding, lost the trust of the management, and there was wastage of resources and a very high attrition. The most fundamental outcome was that the organization failed to see results from AI and ML projects, and the growth got impacted by this. And this was a real story in many organizations, and that set up the path for MLOps. Before we proceed further, let us understand in brief of what an actual machine learning life cycle is. It consists mostly of 5 stages. Everything in machine learning starts with data. So the first big step is data ingestion. Once the data is in, we need to analyze the data, explode the data, clean and transform the data, and make it, machine learning possible. It's possible to do machine learning with that data. So this is called the data processing stage. The third stage is the one which is most talked of by everyone. It is the model engineering stage and is all about creating the perfect model. All right. It is interesting to note at this point that this is just one of the blocks in the entire ML lifecycle. Anyways, so after this stage, we experiment with the model, test and validate the model, and finally deploy the best machine learned model into production. Importantly, the life cycle as machine learned models, the life cycle is a bit repetitive over here, as the machine learned models are highly sensitive to the drifts in the data. And over time, models degrade in performance because the underlying data actually changes. Hence, we need to constantly monitor the performance of the models and trigger retraining and redeployment of the models as and when required. Okay. So once we understand this, we should appreciate that successful operationalization of machine learning models, MLOps as it is called today, would have significant contribution in data gathering, analysis, transformation, cleansing, as well as in model training and development, tracking and versioning, and of course, modulation. And finally, scalable, cost-effective model serving, monitoring, and retraining. So throughout the machine learning lifecycle, MLOps has a role to play. The objective of an MLOps team is to automate the deployment of ML models into the core software system, that is the application, or as a service component by hosting it in a server. So eventually, MLOps introduces a CI/CD system to perform fast and reliable ML model deployment in production with automatic build, test, and deployment of the data, the ML model, and the ML training pipeline as a whole, all the components of the ML training pipeline. Right? That brings us to what is called MLOps now. I think we understand why is MLOps required. Formal definition would be MLOps is a set of practices and tools to deploy and reliably maintain an end-to-end ML lifecycle, which we learned in the last slide. So MLOps was born at the intersection of DevOps, data engineering, and machine learning, and it is very similar in concept to DevOps. It is often called DevOps for machine learning. However, ML systems are much more experimental in nature and have more components that are significantly more complex to build and operate than pure software systems. MLOps practices enable effective collaboration and communication between the data scientists and the operational professionals. Applying these MLOps practices increases the quality, simplifies the management process, and automates the deployment of machine learning and deep learning models in large-scale production environment. So with that, what are the major goals of MLOps? Faster go-to-market, low cost, scalable, quality deployment, and better performance of productionized models, and better management and monitoring of the end-to-end machine learning model lifecycle from data ingestion to deployment of the models. On the right-hand side, what you see is a reference of the paper from Google in 2015 named Hidden Technical Debt in Machine Learning Systems. This is a very, very famous paper that emphasizes the fact that machine learning offers a fantastically powerful toolkit for building useful complex prediction systems very quickly. But it is dangerous to assume that these quick wins is the end of everything, right? Because it is quite common to incur massive ongoing maintenance costs in the real world ML systems. Okay, so we have to be careful with the POCs over here. Picture here vividly depicts that only a small fraction of the real world ML system is composed of the ML code, as shown with a small black box in the middle. The required surrounding infrastructure, which is MLOps to a great extent, is vast and very complex. All right, so now since all these concepts might look just another DevOps for machine learning model deployment, then let us hold on for a minute. Let us understand the difference between DevOps and MLOps. Okay, so MLOps, yes, it can be called DevOps plus, and it has emerged from DevOps. One thing to keep in mind is that ML is all about data. It is just not the code of algorithm which needs attention, but it is the data as well. Okay. So with that, let us quickly dive into the differences. The first point is, unlike DevOps, MLOps is much more experimental in nature. So data practitioners basically tweak various features, hyperparameters, parameters, and models, and they also keep track of and manage both the data as well as the code base of the machine learning models. The next is the hybrid team composition. And it is obvious by now that the team needed to build and deploy models in production will not be composed of software engineers alone, but also data scientists who have an entirely different perspective of software business altogether. Third is testing. Testing of ML systems involve model validation, model training, and so on and so forth. And that is in addition to the usual unit and integration testing which we do in software products. Okay. And of course, automatic deployment and monitoring, which says that you can't just deploy an offline trained ML model as a prediction service. You will need a multi-step pipeline, and this automatically retrains and deploys a model with active monitoring, as we discussed earlier. Okay. So other notable features in the CI/CD pipeline of MLOps, as given from the bottom, where CI is no longer only about testing and validating code, but also testing and validating data, the data schemas, and the models. CD is no longer about single software package or service, but a system, a ML training pipeline that should automatically deploy another service, that is the model prediction service. Right? And CT is altogether a new concept here, unique to ML system that is concerned with automatic retraining and serving the models in production. Okay. So now that we have understood the difference between DevOps and MLOps, let us have some clarification on other related terminologies which often come up in discussion while we are discussing MLOps and add to the confusion. First one is XOps. XOps is an umbrella term which encapsulates everything about operationalizing AI system. That, of course, includes MLOps, ModelOps, DataOps, and AIOps. So AIOps is the use of ML solutions in automating the IT operations, like server and device management, network management, help desk, etc. ModelOps is a superset of MLOps, mostly dealing with governance and the lifecycle management of operationalized AI models and decision models. Okay? And of course, we have DataOps, which is about data management in an enterprise. Okay. So with that, here are the best practices of MLOps that have evolved over the 4 pillars of MLOps principles. That is tracking, automation, monitoring and observability, and of course, the reliability. With these 4 pillars of MLOps, here are some of the best practices in the MLOps world. Multidisciplinary team of data scientists, product managers, data engineers should be communicating and aligning and collaborating regularly on a shared backlog of AI issues. Right? The high volume of data from different sources should be tracked, validated, and labeled. The models should be very simple and interpretable, measurable, and should be versioned in the model registry. Code should be statically analyzed for quality checks and continuously integrated. Deployment should be automated, and a rollback support should be provided. So now, after all these, the million-dollar question is, does your organization at all need MLOps? All right. So here is a set of questions which we should ask ourselves before we start even investing in MLOps. Do you find it difficult to maintain the various tools, languages, and frameworks in data science? Have you increased the investment in ML? Still, it takes high time to deploy a new model to production. Do you have multiple models in your catalog but cannot easily keep track of them all? Are you running ML in a hybrid environment, hybrid cloud or cloud and on-premise systems? Are you supporting multiple types of data workloads? Does your DevOps team monitors performance of all the standard software applications but fail to do so for ML applications? Do you face external regulatory requirements for your ML efforts? And if the answer to one or more of these questions are yes, then start thinking of MLOps today. Right? So now the maturity model of MLOps, suppose we start today, we start from zero. Everyone starts from zero someday. And here is the roadmap towards mature ML practices. Right? So level 0 is the starting level, which consists mostly of manual processes, that is no MLOps at all. It basically involves manual data gathering and model development. However, monitoring of the models is not taken up at this level. Okay. Development of models and operationalization are separate pillars altogether, and there is no streamlined release process followed. Things are a bit chaotic over here. Next is level 1 with continuous training to achieve continuous delivery of model prediction service. Here, the data scientists actually collaborate with the data engineers. Data collection and storage improves. We come out of one single Jupyter notebook, more modularized code. Automated model training, deployment, and active monitoring comes into practice. But this is not enough. So the next level of maturity is level 2, which achieves the highest level of automation in MLOps. So we have proper data lakes and targeted data warehouses here, automated pipelines for data gathering, data analysis and preparation, along with strict comprehensive data governance. This level introduces the CI/CD pipeline. Right? Here you just commit your code, and that can trigger a set of multiple automated activities, which put your ML pipeline directly into production. For awareness, Microsoft has, instead of these 3 levels, Microsoft has defined 5 levels. And in fact, you can define n number of levels. But the basic idea is to step by step reach full automation of the machine learning pipeline. Okay. So before we go to the demo, for people who get overwhelmed by the too many tools and technologies involved in MLOps, we need to remember that you do not need to make MLOps platform from scratch. There are lots of offerings in the market, and you need to choose the one which best suits you. Okay? So we have cloud offerings of AWS SageMaker or Databricks MLflow in Azure, offerings from H2O, DataRobo, and some of the open source offerings like Qflow and MLflow. And we will see the demo of the basic features of one such platform, MLflow, next. All right. Without much delay, let us start with the demo. This is a demo on MLflow, which is a well-established MLOps platform and is open sourced. This Jupyter notebook will demonstrate an end-to-end flow of machine learning model development to deployment. The objective is to get a practical feel of MLOps, which we have discussed till now, its significant features, and how MLOps simplifies the life of machine learning developers or data scientists and data engineers. We will see how to use MLflow to train, test, package a simple machine learning model and how to deploy the machine learning model for inferencing or predicting in a real-time scenario. This tutorial uses a dataset to predict the quality of wine, based on quantitative features like the wine's fixed acidity, pH, residual sugar, etc. So before I start, here are some of the key terminologies. MLflow. MLflow is nothing but a well-adopted open source MLOps platform. Run and experiments. Experiment is a collection of runs. Now, what is a run? So normally, machine learning model is built through iterative training. So multiple trainings are required to come up with an optimum model. Training a model has a lot of steps, which we will see later. And every iteration to come up with a model is called one run. And collection of runs is called an experiment. Now, here are some of the prerequisites which we need to have. We need to have a Python installed in our system. I have installed Anaconda, which is a distribution of Python. We need to install MLflow. You can very easily do that with just pip install MLflow, and we need to install libraries for machine learning. I have used scikit-learn over here. Here are some of the imports which are very regular for any Python program. Now we'll go to the training phase. Before that, let us try to understand machine learning, or how a machine learning model is built theoretically, right? In a nutshell. So a basic machine learning model in this training phase will take some input features and try to map the output, called the labels or classes, to the input features in the training data. And in the process, it will be able to learn a mathematical or logical relationship of the outputs to the inputs. The output in this case is the quality of the wine, right? Now, once trained, in testing phase, it tries to compare the prediction results to the true outputs and determine the quality of the model with an accuracy score. So what you see over here, eval matrix, is a method that will be able to give you that accuracy score of the model. Other thing which you see over here are the hyperparameters, alpha and L1 scores, which control the learning process which I talked of. Okay, so by changing the hyperparameters in this exercise, we will have multiple runs of the model with multiple accuracy scores, out of which we will choose the best one. And we will see how we will do that. Right? Now coming to the training phase. All right? How do we train the model? So the training phase consists of multiple steps where we read the data, prepare the data, and then we fit the model. Basically, we train to come up with the model. We evaluate the metrics, print the metrics, log the metrics, and also save the model for our later use. Okay, so that is what we have done. We have read the data over here, split the data, prepared the data, and now the usage of MLflow tracking API start. Why? Why do we need the MLflow tracking APIs? So that we can track the model parameters and the model evaluation matrix for every run and compare the quality of the models in different runs for our experiment, and finally use that model in production, which gives us the best quality. All right. So here we see that we have, we have a new MLflow, defined a new MLflow run. Then we have trained the model over here. Okay, we have predicted the model, predicted using that model to get the evaluation matrix, and then we log the parameters and the metrics, and also save the model itself as an artifact in MLflow. Right? And here are our evaluation matrix. All right, how good is our model? Now we will see that once we go back and we change the hyperparameters, let us change the hyperparameters over here. Let us change the hyperparameters. And once we change this and we rerun, what we will get are different metrics. See, the metrics over here changed. And everything, all these runs, all the 2 runs which we have done will be tracked by nothing but the MLflow tracking APIs. Now, how do I see that? All right. Seeing that is fairly simple. We just open the command line and type MLflow UI. All right. So once you type MLflow UI, MLflow gives a very nice, so I have done it previously so that it doesn't take much time. All right. So it gives a very nice UI where you get to see all the models, which are all the runs of the experiment which you have done till now. Now you see, this is the model run which we have, we just trained right now, right? And then we get to see which is our best model. For example, in this case, the one which we have run now is the best model. So I decide that I will host this model. What do? I go to this model and I go down and I click on I just copy the file path from here. All right. So this is the file path. All right. So I just copy the file path from here and then I go and host the model. This part is called the model serving. Serving the model is also very simple. What you do is you just go and open a command prompt and just type this. Okay, so this will start hosting the model as a REST API. So if you see over here, this is the model path, which I just copied. So I start hosting the model as REST API. Now the last part, just to figure out that yes, I am able to host the model as a REST API. This I have done earlier so that it doesn't take time. So the last part is invoking the model by the help of curl, because it is a REST API and I should be able to send an HTTP request to get an HTTP response. So what do I send in the HTTP request? And nothing but the parameters of the wine. All right, see the alcohol, chloride, citric acid, density, etc. This is what I sent. Okay, and what I get back, so this is the server which came up and it starts hosting my model, all right, at port 1234, right? And what I get back is the quality of the wine. This completes the demo of MLOps. All right, so with that, I hope we get a feel of MLOps, its basic features, and how or when to adopt MLOps in our organization. Thank you very much for dialing in. I'm very happy to talk to you today in this forum. Thanks so much for joining with me.